Understanding the Fundamentals of Philosophy of Science. Welcome to this section, the Fundamentals of Philosophy of Science. In this section, you will learn how science works, how knowledge is developed, and how we arrive at truth. Have you ever wondered how scientists know what is true, or how scientific knowledge is formed and tested? This section will help you understand what philosophy of science is, and how it is different from science itself. You will also learn the meaning of science, its characteristics, and the methods scientists use to study the world. We will explore important ideas such as induction, deduction, facts, laws, and theories. These are the main approaches used in scientific thinking. You will also learn about the role of philosophers of science and how they help improve scientific knowledge. In addition, we will examine scientific truth, how it is discovered, and how it is explained in science. By the end of this section, you will be able to understand the meaning and purpose of philosophy of science, explain how scientific knowledge is developed, identify the key methods used in science, understand the relationship between science and truth. This knowledge will help you think more critically, understand scientific ideas better, and apply scientific reasoning in everyday life. Let's begin.
Unit 1. What is philosophy of science? Philosophy of science is the study that examines the meaning, methods, structure, and nature of science through logical and analytical reflection. It focuses on understanding scientific concepts, principles, theories, assumptions, and how science should be practiced and taught. It serves as a theoretical guide that helps clarify scientific methods and supports the development of scientific theories in line with empirical findings. Rather than being practical, it provides a framework for interpreting scientific knowledge and shaping a consistent worldview based on scientific evidence. The field also raises fundamental questions about science, including: what is science? What is the nature of scientific knowledge? How does it differ from other forms of knowledge? How do we arrive at a scientific truth? What are the aim and objectives of science? What is the goals and purpose of science? Unit 2. What is science? Science, derived from the Latin scientia, meaning knowledge, is an organized body of knowledge about the physical, material world. It differs from other forms of knowledge by focusing on observable, measurable, and testable facts. Science explains how the world works, including the properties of things and the changes they undergo, using concepts, laws, and theories expressed in quantifiable terms. As a method of acquiring knowledge, science follows systematic procedures such as observation, experimentation, hypothesis formation, testing, and theory development. Empirical sciences rely on observation and experiments, while formal sciences use logical reasoning, rules, and quantitative methods. Science also serves as a practical tool for humans to understand and control their environment through the use of instruments and continuous investigation. Characteristics of science. Key characteristics of science include: it is based on observation, using senses and tools. It relies on experimentation to verify facts. It organizes and classifies phenomena systematically. It studies the nature, structure, and relationships of things in the physical world. Unit 3. Approaches in philosophy of science. Philosophy of science uses several key approaches to study and understand science, including use of induction, use of deduction, establishment of facts, establishment of laws, and use of theories. Let's discuss each of the approaches. Induction involves drawing general conclusions from specific observations. It moves from concrete facts to broader generalizations and helps validate hypotheses using data. Induction starts with observations and builds up to a general conclusion. Example 1. You water 3 different plants every day. All of them grow well. You conclude, water helps plants grow. Example 2. You heat iron and it expands. You heat copper and it expands. You heat aluminum and it expands. From these repeated observations, you conclude all metals expand when heated. So, induction is like spotting a pattern from many cases and forming a rule. Deduction is reasoning from general principles to specific cases. It uses existing theories or assumptions to predict outcomes and solve scientific problems. Deduction starts with a general rule or theory and applies it to a specific case. Example: general rule, all metals expand when heated. Specific case, iron is a metal. Conclusion: iron will expand when heated. So, deduction is using what you already know to predict something specific. Establishment of facts ensures that scientific knowledge is based on real, verifiable situations, making science reliable and authentic. This means science is based on evidence you can observe, test, and verify. Example: water boils at 100 degrees Celsius at sea level. This is accepted as a fact because it has been repeatedly tested and confirmed. Another example: if you drop an object, it falls to the ground. This is observable and repeatable. Facts make science reliable and trustworthy. Establishment of laws involves forming generalizations from observed facts to describe how nature operates. Scientific laws are general statements describing patterns in nature based on many facts. Example: after observing falling objects, scientists form the law of gravity. It states that objects are attracted toward the earth. Another example: Boyle's law. Gas pressure decreases when volume increases, at constant temperature. Laws describe what happens, not necessarily why. Use of theory focuses on developing and applying verified explanations of natural phenomena, helping to organize and explain relationships between variables. These approaches guide how scientific knowledge is developed, validated, and applied. A theory is a well-tested explanation of how or why something happens. Example: theory of evolution explains how living things change over time. Atomic theory explains what matter is made of. Differences from laws. Law describes what happens. Theory explains why it happens. Theories help scientists understand relationships and make predictions.
Thank you for listening. Please subscribe, like, and share the course content to help others benefit as well.